solving by factoring and square root method. Now we're going to talk about how to solve these quadratics. So first we just factored and got them down to parentheses. Now we're going to take that next step and actually solve and find what x is equal to. So as a review, we still have our 4 steps to factoring that we have to be aware of. And that was our GCF, grouping, playing the game, and then if those didn't work, checking, is this a special case? We do have new steps that we have to introduce. Now before we can even GCF, whenever we solve, we have to make sure that it equals 0. That's key. And after we factor, we're then going to solve each factor. All right, so going through these new steps, first, does my example, which I have over here, x squared plus 5x plus 6, and it equals 0. So, check, we have that. Now I need to check, is there a GCF? So can I divide all of these by the same number? No, I can't group. So you can check, did that step. I can't group because there's only 3 terms. Remember, 1, 2, 3. So can I play the game here? Yes. So now I'm going to factor this by playing the game. So remember, there's an imaginary 1 in front. We're going to go 1 times 6, and that gives us 6. All right, I'm going to make my list. I can do 1 times 6, 2 times 3, -1 times -6, or -2 times -3. All of those multiplied together give me a positive 6. Now I'm looking which one, when I add together, gives me that positive 5. And in this case, it's 2 and 3. So I'm going to take the 2 and the 3 and substitute it only back into the middle. All right, so I have x squared plus 2x plus 3x, and then plus 6 at the end, still equals 0. Now I've created my 4 terms, so I can group. I'm going to split this in half, find the GCF of the first 2, which is x. So x goes in front of parentheses, and I'm left with x plus 2. GCF of the second 2 is 3. 3 goes in front of parentheses, and I'm left with x plus 2. Now I know I'm on the right track because my x plus 2's match up. All right, so now I'm going to take one of those. I'm going to take the x plus 2. Then I'm going to take my GCFs, and that creates x plus 3. All of that is still equal to 0. So at this point, all I have done is factor. So I played the game. So I didn't even need to do special case. Now that last step that we introduced, we're solving each factor. So take each parenthesis and set it equal to 0. So I have x plus 2 equals 0, and I have x plus 3 equals 0. And we solve for x. So subtract the 2, and here we get x to equal -2. There's one of my answers. Subtract the 3, and we get x to equal -3. And there's my second answer. So that's really it. That's the only difference when we are solving by factoring, is we just take it that one extra step and solve each parenthesis. All right, we're going to do 2 more examples with solving by factoring. So remember, the first step was to make sure it equals 0. So in this first problem, x squared minus 17x equals -72. So I need it to equal 0, which means I'm going to add 72 to each side. Now 72 is not a like term of x squared or -17x. So all we're left with is x squared minus 17x plus 72. is now equal to 0. Now I can go through my steps of factoring. So I'm first going to look for a GCF. In this case, we don't have a GCF. I can't group, so I'm going to look to play the game. So imaginary 1 times 72 gives me 72. And now I need to list everything that multiplies to 72. All right, there's going to be a lot of these. So we have 1 and 72. We've got 2 and 36. We've got 3 and 24. 4 and 18. 6 and 12. And I believe, yeah, we have 8 and 9. Those are all just the positives. Now remember, we can find the negatives of each of those two. We're trying to figure out, when added together, what creates a negative 17. So if I were to do negative 1 plus negative 72, none of these bigger numbers are going to give me a negative 17. But I do notice if I do 8 plus 9, that gives me positive 17. So if I do negative 8, negative 9, that will give me my negative 17 that I need for the middle. All right, so I'm going to rewrite it. So I have x squared minus 8x minus 9x plus 72 equals 0. Now that I have my four terms, split it in half. GCF of the first two is x. Take an x outside the parentheses, and we're left over with x minus 8. GCF of the second two is negative 9, because remember that first term is negative. And so negative 9 goes to the outside, and we are left with x minus 8. So I'm on the right track because my parentheses match up, which means my factors are the x minus 8 and then my GCFs of x minus 9. Still equals 0. Now you have not solved it yet, this is just factoring. So we take each parenthesis, set it equal to 0, and then we solve. So in this first one, I would add 8, and I get x to equal 8. And then add 9, and I get x to equal 9. And there are my two answers for my second problem. All right, we do have another problem like this. So if you do want to pause the video and try this on your own, go for it. That's great extra practice. I am going to work through this one as well. All right, so first step here, I need it to equal 0. So I'm going to add 6. Again, there are no like terms on this other side, so that leaves me with 2x squared plus 7x plus 6 equals 0. I'm going to look for a GCF. In this case, I don't have a GCF. I cannot group, so I have to play the game. So I do have a number in front, so I'm going to go 2 times 6, which gives me 12. And then if I make my list, I have 1 and 12, 2 times 6, 3 times 4. And I can also use the negative versions of those as well. But for this one, I need to add to a positive 7, which 3 plus 4 gives me that positive 7. So now if I rewrite it, I have 2x squared, then plus 3x, plus 4x, plus 6, still equals 0. Split it in half. GCF of the first two is x, so x goes in front, and I'm left with 2x plus 3. GCF of the second 2 is 2. 2 goes in front, and I'm left with 2x plus 3. All right, my parentheses match. So that creates one factor, 2x plus 3. And then we have x plus 2 as the second factor, still equals 0. And again, last step, set each factor equal to 0, and we solve. So first thing is to subtract 3. All right, that leaves me now with 2x is equal to -3. Divide by 2. So x is equal to -3 over 2. We are going to leave it in fraction form. And fractions can be answers, so that's fine. All right, then we subtract 2 for the other one, and then that leaves me with x is equal to -2. That is our second answer. So there are some examples. It's the same process for each one, solving these quadratics by factoring. We are going to talk about one more method, and that's solving using the square roots, because we are going to see quadratics written like this. Notice it still has the squared, so it's going to be considered a quadratic. But the difference between these problems and the ones we were just working on is that we now have parentheses. So whenever we have these parentheses, we have to use the square root method. So the first thing we need to do is get these parentheses all by themselves. You cannot distribute because it has an exponent, so you can't distribute in this case. So we're going to start by dividing each side by 3. All right, cancels it out in front. So I'm left with x plus 5 squared is equal to 75 divided by 3 is 25. Now, to get rid of the squared, you're going to take the square root. This now leaves us with our x plus 5 equals. Now here is something very important everyone always forgets. If I were to ask you what is the square root of 25, you would tell me 5, which is half correct. The square root of 25 equals 5 because 5 times 5 equals 25. The square root of 25 can also equal -5, because if I do -5 times -5, that also gives me that positive 25. So anytime you take a square root, you need the plus or minus sign in front of your answer. So the square root of 25 is plus or minus 5. Now here's why that's important, is because it's now created two problems for us. So we have x plus 5 equals positive 5, or x plus 5 can equal -5. This is going to get us our two answers that we're looking for. Now all you have to do is solve each of the red equations. So if we subtract 5, we get x to equal 0. Subtract 5, we get x to equal -10. So the square root method is very different from factoring. That's why whenever you see the parentheses, you have to use the square root method. All right, we're going to do a few more practice problems with the square root method. So again, step 1 is to get the parentheses by themselves. So there's nothing in the front or behind, okay? So I don't have to do any division or multiplying, but I do need to get rid of the squared. So I'm going to square root each side, and that leaves me with x plus 1 is equal to plus or minus 3, because the square root of 9 is positive 3 or -3. Now I can create my two problems. So x plus 1 equals 3, x plus 1 equals -3. Subtract the 1, and we get x to equal 2. Subtract the 1, and we get x to equal -4. And there are our two answers. All right, if you want to try the last problem on your own, go ahead and pause the video. If you want to watch, I'm still going to work through this one. So again, need to get the parentheses by itself. So here our first step needs to be subtracting 5. All right, so then that leaves us with x minus 3. And this should be squared. So sorry, this is a typo. This should not be a 3, this should be a 2. It should be squared. So x minus 3 squared is now equal to 36. All right, now to get rid of the squared, we square root each side. So x minus 3 is equal to plus or minus 6. Separate into two problems. X minus 3 equals positive 6. X minus 3 equals -6. Add 3 to each side, and we get x to equal 9. That's one answer. Add 3, and we get x to equal -3. That's our second answer. So sorry for any confusion on this last one. It should have been a 2, not a 3. So if you tried it on your own and got a little messed up, that's my fault. Other than that, those were the two options right now that we're going to use to solve these quadratics: factoring and then the square root method. So feel free to reach out if you have any questions.